Hello, and welcome to our new episode of our Project Spotlight series. We are here from the Excellence Center of Data Science, Artificial Intelligence and Modeling at the University of Hull. My name is Eva Souza and I'm here with our student Caleb. Caleb, can you talk a little bit about yourself and introduce yourself, please?
My name is Caleb. I'm a current master student in AI and Data Science at the University of Hull, and I'm here to speak about my project dissertation.
Okay, so which was the theme of your project and why did you choose it?
My project centers mainly on skin cancer, multimodal models for skin cancer. I chose this because three keywords spoke to me in this project. One was skin cancer, which is being one of the most dangerous cancers in the world, and also multimodal because I want to build a model that mimics how specialists works, in the sense that they take not just visual cues but also take clinical features as evidence, and also interpretable, because I believe that a model that has high accuracy but isn't trustworthy isn't a model that will be deployed in the real world.
Okay, thank you very much. And can you give us a little overview about your project, the objectives, and an opening to the work you developed?
My model is a multimodal skin cancer model. It takes a CNN, which is combined with a VIT, makes it hybrid, and it takes images into the model and also clinical features and combines them together. And those clinical features attend to the images and vice versa. As a result, you have a model that predicts different 7 skin lesion classes.
Okay, it seems very useful. I wanted to you already talked a little bit, but I wanted you to maybe explain us better.
Okay.
Which AI techniques did you use and how do they work?
One of the techniques I used was MedSAM. What MedSAM is a masking model which takes images and creates masks of those images. So in the sense that I use that because I believe that a model shouldn't focus on the surrounding skin but on the lesion itself. So what MedSAM does is that it creates masks of the images, and then those masks are then fed into the model. Also, I used a technique called door razor. What the razor does is that it takes the images and then it erases the artifacts such as rulers and hairs you have on the images. As a result, you have a more clearer and more defined image for the model to use.
Okay, and why did you did those choices in particular, for instance, using CNNs and VITs or the other models of processing of imaging? You decided to choose, why to choose those ones?
So I picked CNN because a CNN is good at extracting local textures and edges that a normal VIT will miss, and then those images are then passed into the VIT, and the VIT does this global attention over those images that are already enriched by the CNN. I also picked door razor because a lot of skin images have artifacts like hair that go in the way of what the model sees. So what door razor does is that it removes those artifacts and produces a clearer image for the model to understand.
Okay, thank you. And I wanted also to ask, how do you think your project could impact the real world? Like, do you think this is something that can be a solution for a real world problem, or just more something theoretical that would not fit so well? How do you see your project within the real problems that exist in skin cancer?
Yeah, I think one way my model can be very useful is for triage support, because we have a lot of skin cancer patients, and as a result, we don't have enough specialists for those patients. So my model can be used to help the specialists to alert him on the very aggressive and important patients we need urgent care. And also my model can be used to help countries that don't have enough specialists and enough machinery.
A way of democratizing screening, skin cancer screening. So I wanted to ask you, were there surprising findings, or your results were something that was expectable? Which insights did you got from your work?
One of them was the fact that clinical features aren't always useful, in the sense that we have some skin cancer that are very, very common, like a nevi, and the model was already enough evidence. Those images were already enough evidence for the model. And when I added the clinical features, it instead hurt the models on those images and helping it. And also, my model is meant to be bidirectional in the sense that images attend to metadata and vice versa. But on further inspection, I realized that the model leaned towards more of the features attending to images, which makes sense because it makes sense for the models to ask, it makes sense for images, it makes sense for features to ask the images, what am I looking at? And images to ask the features, what this image is. So the model attended and leaned more towards the features attending images and image attending features. And also door razor, a technique which I use to remove noise instead hurt the model because the CNN stem is meant to extract local and fine textures from the images, but the door razor instead removes information that the CNN would have used and to predict minority classes and other classes.
Okay, very good. So I wanted to ask you, how do you see your model evolving on the future, or future perspectives future perspectives you have for it? Do you see it be altered, be applied, keep working on it?
Yeah.
Which are your future perspectives for the model you created?
One way is that I would like to add a text decoder in the sense that I could use a text decoder to translate what the model predicted into natural language for everyone to understand. And also, I would also like to try to use some parameter efficient techniques that would help the model be inserted into small smartphones and smaller devices. And also, this will help people in regions that don't have enough specialists be able to just go on their phones, use the model, scan an image, and have an idea of what this cancer might be before they can decide to either escalate the issue to doctors or just until they can start at home by themselves.
Okay. And usually we learn something with work, right? And I always think that when we reach the end of a work, we always think if it started in a different way. Mm-hmm. So my question is in this direction. If you would start work now, or if you need to give advice to another student starting a master project similar to yours or of the same type, what your advice would be?
One will be to not chase accuracy, but chase understanding. Because everyone wants to build the perfect model with the best metrics. And as a result, they ignore other important parts of the models, like having good interpretability, having been able to explain what the model got to other people. And also, I will also advise you to test on external data, because a model that has good metrics on its own data is not enough. A model that has good metrics on other data, as I said before, is a very, very good model. And also, you should try to start your work early and don't underestimate how much work you're going to have, because I personally didn't think I'm going to have a lot of things to go back to, but then later on I realized that if I started early on, I would have found these issues early on and solved them early on.
So, very insightful advice. I also wanted to ask, how do you think working on this project shaped your future career to work in AI or data science? And also your perspectives, your likings within the field?
Yeah. Personally, I always saw AI as something that consumers could use for entertainment, like ChatGPT and the rest. But working on this project has helped me realize that AI can be used in more helpful aspects like healthcare. For example, you have people who don't have access to these equipment, and AI can be used in those regions in healthcare. Also, AI also made this project also made me to understand more that models can be smart but cannot be trustworthy. So I want to build models that are very trustworthy and very fair, not just a particular subgroup of people, but generally.
Explainability is now a big field of AI for healthcare for a reason, right?
Yeah.
Also, I wanted to ask you, if you could expand your project, which additional areas would you include? How would you make it a little bit maybe more more involvement, or with more areas within it?
One will be to import more diverse skin images, because my model was based on mostly lighter skin tones, European skin tones. So I would try to have images from darker regions like Africa or South America, and so as a result to help the model be more fair to other skin subgroups. And also I would try to have more clinical features for the model, because, for example, one of the classes I struggled with was AKIEC. AKIEC is one of the hardest classes of skin cancer to predict, because it has a very visual evidence to other skin class like BKL. So if I had better clinical features for those particular AKIS class, it would help me to distinguish AKIEC from other cancer classes. So yeah, more clinical features and more skin diverse images too.
Thank you very much, Caleb. Congratulations on the project you did. That seems very useful as a way of applying AI for the future. And with us is all today.
Thank you for having me.